Hello guys, hope you're doing well. And as always, if you are new to my channel, I would humbly request you to subscribe to my channel so that you shall be able to watch all my related engineering videos. That will be helpful for you in your future. Thank you. Okay, so the problem at our hand is that we basically have to calculate the product of inertia or product moment of area of the beams cross-sectional area with respect to x and y axis. Okay, so this is a C channel beam, and this is our x-axis, which starting from here and ending at this point, and then basically starting the y-axis starts from here and basically goes along to all that. And just to note that this is our x, from here minus x, this is our y, and if you go down it will minus I. We have to calculate the product moment of area. Okay, just a brief reminder, if you wanted to know what is basically a product moment of area, is basically it is we give it symbolizes as Ixy, which is equals to integral of a xy dA. Okay, so we have to basically calculate the distance of this differential element dA for this area along the x-axis and along the y-axis, which is x and y. Okay, and just to let you know that for this differential area dA over here, this x and y distances which are from the x and y axis can be positive, they can be negative. If this is our first quadrant, and if this area A is basically in the second quadrant, we can automatically see that if this is our origin, then x will be negative and y will be positive. And if we are in the third quadrant and this area is basically over there, we can see that our x and y in the third quadrant will be negative. So you have to be very careful about this x and y, because this product will basically tell you about Ixy quantity coming as positive or negative. Okay, so this is very important. Okay, just to let you know, this product moment of area is a very important quantity, a geometrical quantity, which is symbols are very much different from second moment of area, but the units are basically very much similar to the second moment of area. So let you know that the product moment of area helps us in calculating the maximum, it helps us in calculating the maximum and minimum moment of inertias of the area. These maximum and minimum values are important properties for designing of structural and mechanical members for beams, columns and shafts. So it is very important to calculate. And for the effectiveness of a beam to resist the bending in case of a symmetric or basically skew loading, it can be helpful and can be, because do not only need to calculate the moment of inertia but also the product of inertia needs to be calculated also. Okay, so this is the background and what I wanted to tell you. So let's basically, after this we can go here. So the beam's dimensions are 10 millimeters. One of the distance basically the thickness of this flange, which is basically termed as A, is 10 millimeters. The other flange, which is the flange C, is also 10 millimeters thickness, and its width is 100 millimeters. So is the width of this flange A is 100 millimeters. The height of the height of this web is given as 300 millimeters, and the thickness of the web is also 10 millimeters. Okay, so since we need to calculate the product moment of area, it is very important that we basically give this flange the symbol A, this flange the symbol B, and this flange the symbol C. Okay, so let's basically calculate the product moment of area. Okay, so we know for flange A, the centroid is basically located at this point. Okay, and for the flange C, the centroid is also located at this point. Okay, and what we have done is that basically we have basically changed the dimensions of our flange width over here, and we have, instead of saying it as 100 millimeters, we have changed the flange width as basically, because this is 10 millimeters and this is basically 100 millimeters. So we are taking this web as complete one section, and we are reducing the width of this flange. Okay, so you can say if this is basically 100 and you minus 10 from it, so it's going to be 90. Okay, it's going to be 90. So this is the center. From here to here it will be basically 45, and from here to here it will be 45, just for knowledge. But remember, the distance of this flange A from this y-axis is going to be 45 plus 10, which is 55. Okay, so let's start the calculation. The area of this flange A will be basically given as 90 into 10, which is this 90 into 10. Now we need to calculate from this centroid the distance dx. Okay, the distance dx, which basically starts from here and culminates at the y-axis. So this will be dx. Okay, so you can very easily calculate it as 45 plus 10, which is 55. What about the distance dy? Okay, this distance dy, basically again this is our centroid of segment A, but basically we have to calculate the distance y-axis dy. So this is our x-axis, which he has shown us in the figure. So it will be basically from basically if you go from this point to this point, it is 300. Okay, and this width is basically 10. So basically if we basically minus from 300 5 mm. Okay, so from 300, from this 300, the centroid of this flange is basically located at 5 millimeters from the top. So it will be 300 minus 5 as 295. Now you simply do the simple multiplication, which will be we know from the formula that it is integral of x by dA. So because of this we multiply dx into dy with this area, and we get this quantity. Now we go to flange number C. If you look at it first, okay, it has also the same area, which is 90 into 10. Okay, so 90 into 10, but the centroid location is this point. Okay, so if we need to calculate the dx of this flange C, we can also say from the distance from the y-axis, this is going to be the dx. Okay, so it will be again 45 plus 10, so it will be 55. And but now the dy is basically going to be much lesser, because this is the centroid for flange C and this is our x-axis. Okay, so you can very easily calculate that this distance will be 5 millimeters. Okay, so this is the 5 millimeters, and this is the same. Multiply the three quantities, you will get this value. And what about B? Now B is the whole section that we have basically added over here and reduced our flanges. So you can very easily say that the area for the flange for the web B is going to be 300 into 10, which is here 310. And what will be the dx of this web? It will be from this point to this distance, which is nothing but 5. And what about from this point distance dy, because since this is total 300, so from this point to this point, which is dy, it will be 150. So multiply the three quantities, 310 multiplied by 5 multiplied by 150, and all these three ixy's that you have calculated, if you add them together, you will get your product moment of area summation ixy equals to 17.1 into 10 to the power 6 millimeter 4. Okay, so I hope this methodology of solving product moment of area will help you in your future problems. And not only from the statics point of view, it is also very helpful while solving problems in beam problems for asymmetric bending in mechanics of material or solid mechanics. I thank you all, and you have a wonderful day. Bye.